Welcome to Tetrate Tech Talks. My name is Eitan Suez, and this is episode 11. Thank you for joining us. Give me just a second to share with you another screen here. What you're looking at here is the landing page for the Tetrate Tech Talks. The URL is right there below. And this is a great way for you to grab all the links and everything we're going to be discussing in this episode. We have a special episode lined up for you. My name is Eitan Suez, the host of Tetrate Tech Talks, where we talk about technology, specifically around service meshes. And today is episode 11, Friday, June 17, 9 a.m. Pacific, noon Eastern. Thank you for joining us. So a little bit about these Tech Talks, if this is the first time that you're visiting, it's all about learning and sharing knowledge and talking technology, getting to know the diverse members of the service mesh community, and above all, to have a great deal of fun. I'm your host, Eitan Suez, and I'll make this a little bit bigger so y'all can see. And just a quick recap, we run these Tech Talks every Friday. 2 weeks ago, we had a lively conversation about the Tetrate Istio certification exam. So if you've missed that, all our episodes are recorded and available on our YouTube playlist. And last week, we had the pleasure of talking with Tetrate engineer Jose Carlos Chavez on web application firewalls. So if that's a topic that you find interesting, definitely check that out. All right, so without further ado, in this episode, we invite Kelsey Hightower to have a conversation on service meshes. And basically, we want to know Kelsey's thoughts on this technology, and we'll be talking about a variety of topics from Istio's value proposition to where we stand today. Kelsey is a principal engineer at Google. And let me bring him on. He is co-author of Kubernetes Up and Running, and also author of the very popular tutorial Kubernetes the Hard Way, among many, many other things. So Kelsey, thank you for coming. It's a pleasure to have you. And I'd like to give you the opportunity to properly introduce yourself.
Yeah, I think that's a good summary of the last maybe 5 or 7 years. I spent a lot of time at Google Cloud, but I like to think of myself as a practitioner, like most people that are probably watching this. I've had all those jobs: system administrator, software developer. I've been the manager, the people or the person who those people reported to. And I also like my time contributing to open source, from small libraries to some of the larger frameworks people are using in the industry, and also just someone who's generally curious. And of course, through that curiosity, I have a ton of opinions about the technical landscape.
That's wonderful. Okay, and I've got a whole line of topics. I don't want to think of it as interrogation, but rather a pleasant interview. Topics to sort of orient us to what we're going to be discussing. So let me go ahead and add to the stream real quick a diagram. The first thing I'd like to discuss with you is this diagram here. This is obviously the very well-known CNCF landscape, which is so crowded that we can't really make out anything. It looks almost like looking at integrated circuit from very, very far away, because there's so much detail. And what you see in that little red circle there is the service mesh component, or that corner of that universe, which looks kind of tiny from this vantage point. And so my question are along the lines of, okay, well, you got this enormous ecosystem, so many technologies, and it feels like service mesh is a small fish in that larger ocean. And in your opinion, is this service mesh fish in any way unique or special, or is it just one of many technologies that folks need to sort of get their arms around and comprehend? It seems like a daunting task.
Yeah, I mean, I think the important thing here is there is a big picture. Typically we're leveraging any number of these squares to do something. So ideally, that is your big picture, whatever business, service, product that you're actually building. And so I think it kind of makes sense to ask yourself, what is this particular section on this landscape actually doing? And I think for people that are leveraging the other pictures or squares to build things like gRPC, for example, or maybe you're using something like Helm to describe your configuration, or Flux to manage that configuration as you're rolling it out to production. There's this part where we know, just from experience, if I have two things trying to talk to each other, whether it's a client and a server, or two services that are dependent on each other, there's going to be some things that we're going to have to do to ensure like the right two things are talking to each other. They're talking about the right things. And so that's where policy comes in. And I think the biggest debate that we do in the industry, or where we go back and forth, where does this logic belong? Right? Should we put this in the application itself? So if you're writing maybe a Java application, maybe you go with the library that does all of these things, or you go with an application container. I think the service mesh has been more of a generic approach of saying, maybe we can put a lot of this logic, retries, observability, network policy management, all the way at the protocol layer. Maybe we can put it at the network. And if we put it at the network, how close to the app should we put it? And I think once we started to say that it should be very close to the app, I think that's when we started calling it service mesh. Because a lot of these fundamentals, I think people were doing with the standard load balancer architecture. But now that we're doing this, and I think the last thing I'll say here is we're adding identity to the mix. I think that's the biggest change. So if you're coming from the load balancer world, you're probably saying, I've already were doing rate limiting when I was using something like Nginx. I was already doing MTLS between my clients and my load balancer. Why is this so different? Why are we talking about this all of a sudden? I think it's when you think about the mental gymnastics required to say, let's take that proxy, put it next to the application, but also give it an identity. And now that identity becomes something that you can actually do even more granular policies on. And I think that's when this whole service mesh thing starts to make a lot more sense.
I like that very much. As a matter of fact, that's a topic that I wanted to grill you on a little bit further. But let me set a little bit of context before I get there. The technology, Istio specifically, just had its 5th birthday recently, in May, I think it was. And so it's a technology that's been around for some time. You can't call it new anymore, but maybe you could say that it's evolved and matured. That's definitely true. And it's important to ask ourselves, well, where are we today? Where is this thing going? What is the state of affairs? And to me, it helps me orient myself when I think about, well, okay, what is the one sentence? And that's such a hard thing to do, to describe something. Maybe that's, I don't know exactly how many lines of code are represented by Istio down to one sentence. But when I look at the Istio website, their tagline is to simplify observability, traffic management, security, and policy. And that sounds like so much, right? I mean, usually you think of one tool and it does one thing and one thing well. Are we sort of breaking that rule here? What's going on?
I mean, I think in the network is where a lot of these things come together naturally. So you can get a lot of observability done via the network. The network is also a security boundary that you're going to have to deal with at some point. And so when you see all of these things, it's because that's probably the easiest place to inject things to actually influence all those things that I mentioned on the website. Now, can you make it easy? Well, that's debatable, right? Because some people would say service mesh is complex.
Right.
Well, you know what's complex? Getting a VM, installing like 700 security agents, getting a firewall, dividing up 10,000 policies based on IP addresses and ports, which we all know do not necessarily map to any of the applications running. But then we all try to kind of fool ourselves that we do all of these things. And in any of these equations, we're still not being explicit about the thing we're trying to actually protect. And so I think when we start to say, hey, let's be more explicit. There's an application. It needs an identity. And then from there, we will build out all the other things. And it just turns out there's this really cool opportunity to say, well, typically what we're protecting is the thing communicating to other things. And so that's why I think the service mesh has become kind of the destination where we want to put those capabilities. And also we want to prevent mistakes. So all the things you've listed, we could ask all developers to do the right thing and just write that kind of code in all their applications. But we don't control every application. And sometimes we don't have time, or we don't have great libraries for every programming language or every programming environment to make that happen. So I think the service mesh is finding this opportunity that right there at the network layer, close to the application, we might have a way to unify some aspects of all of the things you just mentioned.
Yeah, I'm reminded by in our first episode, I had an interview with a colleague. His name is Bart Van Bos. He's based out of Belgium, and uh, we had a similar conversation, and he said to me something very similar. He said, if of all the things that a tool is designed to solve, look at the problems that enterprises have today and just pick the one, security. That is such a big deal. And he was harkening back to the days when before we had, for example, two-phase authentication, just username and password, and how almost overnight that just became adopted and it made our lives easier, things more secure. And he was trying to make the same case that you're making here about security. And I actually have the diagram from the Istio website. I'm going to share it with our audience. I think it's right here, and this is one of the canonical diagrams, by the way, from the Istio website that shows something that happens implicitly, right, in Istio. The fact that when a workload is deployed, not only does it get a sidecar, but there's this whole negotiation with Istio and a certificate authority to issue an identity to each workload. And when I think of the state of affairs today, I don't know. I doubt that most organizations have that in place today. They've got maybe a walled garden, maybe a lot of security on the perimeter, but maybe not on the inside of their distributed architecture, which could prove to be problematic.
And we should break this down for people. Like if you look at that diagram,
Yep. Let me bring it up again.
You might say, hey, this is super complex, right? Because the role of identity is somewhat complex. Think about your driver's license or your passport. I need to make sure that I'm issuing it to you. Who are you? And ideally, I'm not issuing the same identity to someone else, because then all things tend to break down if we're both walking around with the exact same identity. I can't really start to apply things to a certain individual. So in this diagram, what makes this hard is because at some point there is a root of trust. So we're going to agree that we're going to trust the certificate authority. And if you have any experience with certificate authority or PKI in general, public key infrastructure, this can be hard, just finding the right tool to set it up. But let's say you do. The next challenge you have is, while you can create these certificates, you can go to the extreme, one certificate per instance of a binary, or some people will do things, one certificate shared by many services that compose that, thing. So you may go from 1 to 5 instances. Maybe they're sharing a similar certificate. There's many ways of doing this. But the hard part for most people is distributing the certificate to the application that needs it. And what most people are doing today is literally SCPing, maybe using something like Puppet Chef or Ansible. And now you're copying these files around. And so if you're going to be copying files around, then you're probably not going to go for something that's going to expire in every 10 minutes, because then every 10 minutes you're sitting there rerunning all of these things with your configuration management tool. It's doable, but now we start to have a problem. What server are you copying these certificates to? Why do you trust that server to hold that certificate? And also, who has access to that certificate once it lands on the server? So at that point, whoever holds this certificate now assumes this identity. And so what we've been trying to do in concert with the runtimes is to only allocate that certificate to the application that needs it. And this is why it's so important, I think, with the sidecar model, is to have kind of this late binding approach of, I know exactly who you are. I know what IP address you have. Sometimes we can get down to, I even know the binary signature that I'm allocating the certificate to make sure that I'm limiting who can use the certificate. And I think that's a real big game changer here. So when you see that part of the stack, that's just one component of service mesh, Istio and Envoy in particular, is this point of like, we can give this granular identity, which is the precursor for having these well-defined policies. You get this step wrong, then I think everything else falls apart.
Yeah, this is foundational, isn't it? Yeah. Okay, so I'm going to segue from this to a discussion on enterprise readiness for service mesh. And the first thing that comes to my mind is maybe the false impression that maybe might exist that I think of myself now as some kind of IT manager, and I've got all of these workloads running on servers, and I feel like, okay, I've got enough work right now to deal with moving my workloads to Kubernetes. Maybe I'll wait until that's done before looking at something else like service mesh. And in truth, you don't really need to onboard your workloads to Kubernetes to take advantage of service mesh, and that's maybe something that's not really so well known. Um, and so, I think that's maybe what's changed in the last 5 years. And I don't know if it has, or to the degree to which a large organization can move. That's always been sort of the challenge, right? Is, small, agile companies can go very fast, but when you're a behemoth, it's not simple.
Yeah, I
Yeah,
think I think a big part of the problem is that a lot of these tools are just presented as tools, and no one really knows why they exist. Like, it's like going to the Home Depot or department store or hardware store and just
yeah,
walking down all the aisles. Hey, what's that? That's a jackhammer, sir. Do
right.
I need one of those? I don't know. What are you trying to do? I don't know. I mean, I have concrete, I have a driveway. Maybe I need a jackhammer. It's like, sir, no, you you,
That's not
you
how it
don't need a
works.
jack. My
Yeah,
neighbor has one though, but they work in construction. They need a jackhammer. That's what they do for a living. That's why they came and bought one. You don't work in construction. You don't need a jackhammer. And so I think in our industry, a lot of things are just people walking up and down the aisles trying to figure out if they need a tool or not. So it gets really confusing. Or in our industry, someone from our house goes to the store, they buy a tool because it looks good, they bring it home, and they lay it in front of everyone and say, "Hey, look at this. This is cool. What are we
yeah.
gonna do with it? I don't know. I mean, it seems like we should have one, right?" Like, they had them, they were on sale. I saw a lot of people buying them. I figured I should buy one too. And then you take it home and you have no use for it. That's where I think
Right,
a lot of people are struggling because they're trying to do this cargo cult of like, well, they have one, I need one. But I
right,
think having a problem, and look, this is just the easiest way to identify the right tool for the job. You have a leaky faucet. You look around and you notice that you need to tighten a screw to stop the leak. Now you have a sense of urgency. The
wow,
problem is super clear. So when you go to the store, they'll say, well, what's going on? I have a leaky faucet. So, oh, you have a leaky faucet? Faucets are usually about this side. You need this wrench. Oh,
right.
sweet. Thank you. You go home, you tighten the faucet, and the leak stops. And you keep that tool around because you know what it's good for. I think a lot of people haven't gone through this exercise. So if you're an enterprise, you probably have a leaky faucet. It's just not flooding the house. The water bill is not too high, so you have no sense of urgency. But I do think when people are brought, maybe service mesh or introduced it to them, I like to challenge a company and say, what is on your infrastructure roadmap? What would you have liked to have? And they say, well, we wanted better orchestration. Maybe we have some custom scripts, or maybe we're using configuration management. So Kubernetes became attractive because I know where I came from and I know the things I was yet to build. So using Kubernetes as an orchestration layer just makes a ton of sense. And then when we say, well, what about security between app to app communication? How are you dealing with metrics? How are you dealing with identity? And if you phrase it that way, they say, "Oh yeah, we don't quite have a solution for those things quite yet." And I also like to say as well, there are ways you can do this without a service mesh. Here's what those things look like. And then if that sounds like overwhelming, then maybe this is a good solution. So now we're starting to give people the tools that they need. So when we say enterprise ready, I don't know if we're explaining things correctly to
Right.
the typical enterprise. We got to help them identify the challenges they already have, not trying to solve
Yeah.
challenges they may or may not have now or in the future.
That's a powerful analogy. I love it. Yeah. And maybe the suggestion or the lesson there, or one of the lessons is you got to look at your problems and how to solve them as the sort of the head of your spear. And then everything else falls into place. Then you figure out what tool you need for the job and so on.
Understand the problem too. Like, you got to understand it and understand what happens if you don't fix it. So a lot of people are aware that they don't have any encryption inside of the network. They're aware. But for them, they may not feel anything about that. It's like, well, we have really great firewalls. Matter of fact, we have
Right.
3 firewalls. You got to break through all 3 firewalls. And then you remind them, aren't you opening port 443 in all 3 firewalls? You have a big door, you have a tunnel into your network. So all of that firewall stuff isn't really doing anything when it comes to some of these types of attacks. And so now you just got to make it clear, if you do nothing, here's the consequence. And that's why that leaky faucet, you know what happens if you do nothing. You're going to flood your house. That's bad. So I think a lot of people are aware, but they don't understand the impact of doing nothing. And I think that's where
Right.
us, as people that build this stuff, we got to do a much better job of explaining how bad the problem could be if it goes unattended.
Yeah. Yeah. All right. There's another metaphor I want to bring up, and this is, I guess, I lean back a lot on my background, which is primarily more on the developer side than the operations side of the house. And so I remember, being on development teams, and there was always this sort of dichotomy between libraries, software libraries on the one hand, and frameworks on the other hand. And the fact that maybe frameworks are more invasive, right? The library is easy. It doesn't require as much risk for you to take on, because you try it out. If you don't like it, you can discard it or replace it with another, or it doesn't alter the architecture or your design. But with a framework, it feels more invasive. You feel like maybe your code becomes intertwined with the framework. Maybe there's this kind of a relationship there, and hooks that are really hard to pry off when you want to move off to something else. And so when I look at that at the platform level, and look at CNCF technologies like maybe Grafana or Prometheus, they feel more like libraries. They're components. I can choose to use them. And if I want to migrate later to another monitoring solution, it's not going to necessarily impact my architecture. But does service mesh feel more like a framework? Is it more invasive? Does it have hooks into your code base or anything like that? I'm trying to think about, maybe is that create a little bit of reticence on the part of an adopter to maybe put the brakes on?
Yeah, so I think it's good to know kind of the evolution of these things, right? Like if you have a programming language with no standard library, that means you get to figure out everything and you will write it every single time, right? So if you just take, I don't know, like the C programming language without glibc or something, and you're just going to write everything yourself. I mean, you might even want to write your TCP/IP stack yourself. Like it's up to you. But eventually you start to say, this doesn't make sense to rewrite all of this every time. And then we start moving things into either a library, so we can just reuse the same code. So then you end up with something like glibc. And I think libraries are all about composability, right? I need an HTTP handler. I need something that can actually implement the TLS protocol. Great. So the libraries allow us to compose things to get whatever we want. So, but eventually, when you start building larger applications, and all developers know this, eventually even the composition becomes tedious. Why am I always initiating the handler, setting up a TLS certificate, binding the certificate, extracting out the subject name, and then deserializing the body that comes in? Why am I doing that over and over again? If that's
Right.
going to be common, then let's make an HTTP framework that takes all the libraries and then turns it into an opinionated thing to get done. And that works. The framework model tends to work really great when it comes to like a single language stack with a rich library ecosystem. So you pick best of breed and you come through with the framework, and that framework is going to be way more opinionated. You need to do your HTTP paths this way.
This way, right?
If you do it this way, then we can use convention over configuration, right? So we can just say, we can parse parameters out automatically. We can deserialize, and then we end up with things like gRPC and JSON RPC. So you can go even further where frameworks become protocols, right? And so now you have that. And so that's like, oh, this is amazing. But what happens when you need to support every programming language that exists today and the ones that need to exist tomorrow? So a lot of these frameworks that we had 10 years ago,
Right, right,
there
right.
was no Rust. There was no Golang. I mean, maybe there was Golang, but it was in its early days. So given the fact that something, now you got to go and implement the entire framework in the new programming language, and then you get this bit of lag. You get the mature things where people are using the framework quite a bit, and you get some projects where We see this with gRPC. PHP and Ruby are probably not as mature as Java, C++, and probably Golang at this point. So then you're not necessarily getting the same benefit from the frameworks because it's so language dependent. Now, to get back to your original question and maybe your original point, when we move these into separate binaries, that concept of a sidecar, right? And you all know this. Remember the LAMP stack, right? You would write your application, maybe PHP or Perl, and we would bring Apache or Nginx to be the thing that took the traffic, and we would implement all of our logic there one time, and then let that execute our code. And then our code could be just simpler. We don't need to implement rate limiting in every piece of code that we write. And I think Envoy just doubles down on that. Let's take the concept of an application server or framework and move it to a dedicated process. That means we don't need to support every programming language in terms of logic and implementation detail. We now have something that we can trust to work the same way, regardless of what library, language, or framework is sitting in front of. And then we make that programmable. And now I think so I would say it borders between framework and platform. Okay. And I think it leans more towards the platform component. And inside, if you go inside of Envoy, I think Envoy itself is a framework, right? There's extension points that you can actually say, call it to your own authorization layer. But there's a clear protocol that says, I'm only going to pass you a subset of the information on the request so you can make a decision, and you must respond this way. And so that's how you stay in the framework category. So Service Mesh is a platform at the lowest level, a framework in the middle, and it supports any library that you want to implement on your application side. And I think that's going to keep everything super clean.
Thank you. I've given this some thought myself, and I went back to, the canonical diagram. I'll go ahead and flash it up here on the screen for Istio, right? And this is, I'm sure everybody's seen this before. And I had this realization just the other day that if you look at that green rectangle in the background, the one that's labeled mesh, just behind mesh traffic, if you think of the top of that rectangle as the waterline, and consider the proxy as being part of the infrastructure, really, and Istio, of course, which is configuring those proxies part of the infrastructure, then it either feels like a really well done framework, or a framework that's so not invasive that if you were to pick up your services and move them somewhere else later on, there are no hooks that you have to sort of patch later on. And that was I think I landed very close to what you just said, that it's
so here's where I think it's
between
probably, I'll challenge the invasive part just a little.
Okay.
So let's think about, in reality, most people already have their applications written. They have a way of deploying, whether it's VMs or Kubernetes or whatever. And those apps are talking to each other today, point to point. And so now, in order to use this, I got to inject something in the middle of that communication channel. So typically, that's going to be some downtime. I'm going to have to redeploy something. I'm going to have to change the point to point to be, instead of service A talking to service B, now I got to go and say, well, you can't own that top line IP and port anymore. I got to go hand over 443 to my proxy, or intercept the traffic via the kernel or some IP table tricks. But either way, we got to move the front door, right? The front door was over here. We now got to go remodel the house and move the front door. And for a lot of people, like, yo, I'm not trying to move stuff around. Like, we ain't trying to move no windows around. And so now companies have to figure out, how do I do this without necessarily disrupting everything? And this is where it feels invasive, because it's just not a drop in. Now, if you got a new deployment, I think some people, I've seen them do it well, where they'll start with maybe one app. On the next deployment, we're going to have Envoy in there, and it's going to become the front door to the application. And the rest of the apps don't really need to know that it is happening. They're going to make the request that they want, but now you got to be careful. You can't just go turn on require TLS mutual off, because the other apps don't have a certificate yet. So you're going to have to kind of slow down and say, well, I might just start with observability, because that's the only thing I can really get without hurting everything else. Okay, that might feel more like a non-invasive feature you can turn on. But then maybe you start to get to the point where you're going to do a separate deployment for service B. And given that separate deployment, you might require that service A and B talk to each other using TLS mutual auth. But again, you can't do that for the whole stack yet because they all don't have their certificates. So I think that's where most companies struggle. Like, how do I introduce this progressively
Right.
without blowing everything up? Because I've seen people try to do it. They'll say, hey, we mandate everyone start using service mesh, and they install it and they turn it on, and they're like, okay, and they have no policies yet. There's no rules yet. So everything is still open. And then maybe they get some observability and they're like, look, we got graphs, and everyone does a little dance. Everyone has a party. And then they just say, all right, require MTLS, and boom, things are
Yeah.
breaking because they didn't realize that things that talk to your apps may not be in the service mesh, and now nothing is working again. And so now you got to understand, you got to slow down, think about this, and get that configuration right, and progressively roll this thing out over time.
Yeah. Yeah. I see. Peter mentioned permissive mode, how that's basically one of the toggles in Istio that you can turn on to sort of support that use case. I think that's really wise advice. As a matter of fact, so there's all these things you could do with service mesh, but I think that the idea of one thing at a time is always been wise. Let's decide on one thing we want to adopt that we can wrap our head around, build some experience with, and then go on to the next step. And so that leads me to another question. This idea, and I think we've already answered this question, but usually when you try to adopt a new technology, at least for a transitional period of time, there's a little bit of chaos that gets introduced. And the promise, of course, is that if you get over that, then you get to a higher plateau. But some technologies create more chaos than others, and some promise to create more harmony. So the question is, does service mesh help or hinder? I think it's kind of a hard question to answer because it's very open-ended. You need context, maybe. But in general, maybe you can.
I remember when I bought my first house, and I was really super happy. But then I realized that I probably need a security system. And then so the security person comes in, and the first thing they do is don't tell you to hire like an armed guard to stand in front of your door. That's expensive. That's weird too, right? Like, can't even afford it. But so then you don't do that. So typically we put in some observability, right? You put the contacts on the windows. You actually look at your situation. This is the back door. How secure is it? This is the front window. How secure is that? What's the probability that someone's going to come in through this window versus this window? And so once you kind of do that mapping, you prioritize where you're going to put those window contacts, the door contacts. Maybe you can get a camera. Maybe you get a motion sensor. Do you have a dog? If you don't have a dog, then there's certain things you can do and you might want to do. So once you kind of lay things out, you put the contacts. Now you're kind of in observe mode, right? So when the door opens, you hear something. When the door closes, okay. And then if you're going to be away, you can start to set policies. And I think that's the second step, right? So once I get observability in place, I can observe what's happening, maybe get notified when something seems abnormal. The next thing we want to do is put a policy. And that's when you start to say, hey, I want to have a stay mode, right? We're all in the house. I don't expect anyone to be leaving. So if any door is open,
Right.
we want to just sound the alarm immediately. So I think that's kind of a good way to like bring in the features that you need. But I think that's where a company has to kind of think about this is like, what am I getting out of this particular package that I'm deciding to inject in my infrastructure? And for most people, it's going to be the programmability of making those decisions. I think that's the big difference here. So for a lot of people, it's like, hey, just get the security system installed. We'll figure out policy later, but let's just get that there, make sure that nothing's broken, make sure the foundation is
Right.
laid and is clear. Then we have to teach people how to use the system, right? My mom is like, hey, or I teach my daughter, hey, here's the keypad, here is your code. So when you come home from school, type in the code, disable the alarm, and then I can get a notification that you're here now. So now she has an identity to do things in the system. I think that's the way most people need to think about this. So it's not all or nothing. It's a foundational technology which we can actually do and make decisions and then implement them programmatically. So that's the way I like to think of it. There's a big space here if you overcomplicate things, but it's really about figuring out what you need, making those decisions, and injecting that configuration in the mesh itself.
Yeah, I love this metaphor. It's really powerful. I mean, this idea that you can do things in a very procedural way, and along the way, you build up confidence and experience with the thing that and you're making progress, and that feels good. So that's that. Thank you for that. I really appreciate it. All right. So another analogy, or at least a perspective. And I'll admit, for a long time, I was one of those laggards who was very happy as a developer in my cocoon of, I remember the day back the days long ago when the domain of the programmer was just their process boundary. That was their world, and they cared about modeling things and objects and inheritance and maybe other things like that. And obviously, the world has changed dramatically. And for good reason, and for the better over time. Like the two worlds, the development and operations, the one that's looking outwards at the operating system, the network, the systems are merging. And I think I'm starting to see it. And the line becomes increasingly blurry. We've got containers, and I've been looking at WebAssembly and how it promises to even make the line even more blurry. And so the question is, does service mesh have a positive influence on the picture? Can it help further harmonize the two worlds? The fact that you have DevSecOps, that they all must live together in harmony, um, from where we've come from, back in the day when they were silos, really.
So here's the thing, like I'm one of those people that don't think silos are bad. They're only bad when there's no API. When there's no contract, then it's just chaos. It feels noisy. It feels like a big distraction, a waste of time. And so you have to force people to work together to do common things. To me, that's actually bad. All of
Okay.
these teams have to work together so often because there's no contract, there's no API. Think about any other real utility, right? Your goal is to build a platform that becomes a utility. So if I want to plug something up in my house, I can go buy an electronical appliance and just plug it into the wall. I don't have to
Okay.
do DevOps at home. Oh, okay, let's go do something with the power grid. Let's stand up some poles. Let's repair the wires. And then let's like install jacks all over the house. Like, who does that? That's not that's not healthy. So my power company, they're a silo. I don't talk to those people. I don't even know them. Right? Is that bad? Is that a bad silo? Should we be going to lunch all the time so we can talk about power voltage? No. The contract is very clear. There's a socket in the wall. I plug things in, nothing breaks. This is beautiful. So now I can go
Yeah.
focus on using my electronics, not becoming an electrical engineer. I think the state of things where we are now, we're asking everyone to become an electrical engineer, understand the
Yeah.
power grid. When you put up that landscape, all of these pieces are so that we can eventually get to a point where you say, listen, developer, listen, if you use gRPC or HTTP, if you use this header to identify the thing upstream, if you call out to this endpoint for your policy decision, if you log in this way, if you expose slash metrics, I will do everything else. If the machine fails, I will move you to a new machine. Why do you care? I will
Right.
make sure that the only things talking to you are the things that should be talking to you. Right? You don't have to figure all of that
Yeah.
out. And to be sure, maybe you can double check. I'll give you a signed token so you can verify that anything that does make it to you, that it's traveled through the right path. And maybe you can go verify that, hey, this JOT token that has some scopes and some additional metadata, just go verify. But other than that, you don't need to know about Envoy. You don't need to know about Istio, Kubernetes, serverless, VMs. Why? These are all implementation details. So if you're a platform engineer and you want to provide like the ultimate utility, yes, the service mesh becomes a way to say, I can do rate limiting for you because I have a platform which allows me to express that. So I think the end game then becomes these are the interfaces that if you implement them, you will get power, right? If you have something that plugs into the wall, I promise you, you will get power when you plug it in. But then we need the policy piece. And this is where I think Istio and these things attempt to help. As a developer, I'm the one that might need to tell you what my dependencies are. These three applications can talk to me. I require these identities and only these paths. And so now we can have a conversation. So when I think about what should the silos do or the independent departments be doing, well, they should be communicating, but not necessarily with Jira tickets and big long docs and SharePoint. they should be communicating over an API. And for some companies, that will be as low level as their Istio manifest, or some high level thing that takes into account their needs on the metric side, their security side, all rolled up into one, and then serialize to all of these lower level configuration needs. And I think that is really the end game when we talk about building platforms for our developers.
Wow, thank you. All right, I'm going to put you on the spot for a minute as I was, look back at the watching recordings of conversations you've had at different conferences. The two that stand out that really amazed me. One of the things that I really love about how you explain technology, and you're doing it right now, is that you're leaning on familiar metaphors, familiar analogies, and there was one specifically where you talked about the Kubernetes scheduler. And you said something along the lines of letting Kubernetes play Tetris on your infrastructure. And my mind was like blown because it's such a powerful, you understand Tetris. We all, spent a few hours at least, right, trying to make everything fit. And it was really, I think, very well done. And the other one that I want to bring up, because I think it's more apropos to our conversation, is one, I think it was a fireside chat you had with Joe Duffy maybe 8 months ago or so, where you talked about transportation infrastructure, the fact that we don't think about the road that we drive on every single day, unless there's a pothole, which is maybe more of an exception than a rule most of the time. But that in software, in the software landscape, oftentimes the situation is completely the inverse, whereby you've got the team having to build the highway, or they find that there's the missing bridge that they're going to have to build before they can even maybe funnel their data over from one side to the other. And that was, again, a very, very powerful infrastructure. Very powerful analogy, a metaphor. And so that brings me to, and this requires a lot of explanation, I really apologize, this thought that, okay, here are all these companies going on this journey from monolith to microservices, right? And different companies, obviously, at different stages have had to go through it. I guess Amazon was one of the early ones, and then there was Netflix, of course, and they've had to build the libraries that they needed almost in real time as they were moving their infrastructure to AWS. I love the story Matt Klein talks about Lyft. When they actually had to build this proxy, the development teams were really stuck. They couldn't move forward. And this experience of moving from one place to another took months, if not years. And I like to invoke the term a dark art, like that the process of a company going from point A to point B is really a circuitous, journey through the Mirkwood, where there are dragons and all kinds of pitfalls waiting for them. And the reason I like to paint that picture is because I think I've been spending a lot of time with Service Mesh, and I think I see the light at the end of the tunnel. I think Service Mesh says, okay, here's a platform that brings you all the things that you're going to need in a distributed application. You're going to need service discovery. You're going to need client-side load balancing. You're going to need traffic management, and we got you covered. Right. So is that going too far? Is that, I think it's a bold claim to say that Service Mesh can solve that problem. Are we going to see companies suddenly, fly through this process? Probably not. Right.
Yeah. I mean, so, one thing I think that we're all guilty of in the software world is a lot of the things that we build are actually a response to the problems we created before.
Wow. Okay.
And unless we can have that retrospective, we might be making things worse. And there is no one to stop us, because no one knows whether this is the right approach or not. That's how immature our industry actually is. Is the monolith actually bad? Probably not, actually. It is hard to work on when there's lots of people working in the same thing.
Right.
Having people trying to build a house at the same time, that's hard because the boundaries aren't clear. But it is easier when we talk about houses because we know that the plumbing and the foundation have to come first. Then you can frame. You can't put the roof on before the framing is done. That everyone knows that. So some things can be paralyzed, some things cannot. And they have centuries of building things this way. So it's a very mature industry. In software,
right.
monoliths, the problem to monoliths could be write modular libraries and then bring them together at integration time and deploy all the services at once. That has been working for lots of people, but sometimes we conflate the ability to create clean boundaries. Maybe we're practicing object-oriented programming the wrong way.
Right.
Maybe we're intermixing code the wrong way. And so once we start making a mess, sometimes we over respond. I'm not saying that it's not always the right case or always wrong to create a microservice, but maybe there's a step in between that says, how about we create modular code that can be tested independently, but then we wire it up for deploy time, and then we reduce the number of network hops. We reduce all this weird stuff about what's talking to what, and we can enforce it at the code boundary. But instead, some people said maybe it's easier, and in some cases it is, to separate these into two different binaries, serialize the communication. And you know what you get from serializing communication? You get the ability to be very explicit about how two services communicate. It's just a hard boundary.
The contract.
Yeah, I got a contract now. I got to make a request. I got to give it this input, and then I got to get this output. You can do that in the same code base, but oftentimes we will just cheat. You just extend this base class, even though you're not supposed to touch it. You violated the contract. It's just harder to violate contracts the higher you go up the stack. And I think people found relief in that and said, oh, great. Now this team can have their own repository. They can implement their entire service. But the cost of doing that is that now you need something like a service mesh to fill in all the gaps that you just introduced because of this decision you've just made. So I think we got to make sure that we're really clear, because it's okay to have many monoliths. You might have 4 large monoliths and still benefit from service mesh, because these monoliths still need to communicate with each other. Now you still may call another service, and that service needs some protection as well, even if it's also having 5 or 8 different services built in. So I think as a software industry, we have to realize what looks like progress could be causing the collapse. And I've seen a lot of companies do that themselves. They keep adding and adding until the whole thing blows up and is no longer usable. And then they try to go back to the drawing board and say, we have to refactor this. But usually in that refactor, they try to learn a few lessons, and we try to simplify over time. So I do think this is a good response to the issues we've caused through microservices. But we may have to ask ourselves, is this the right approach in general? And I do think it does have use cases beyond just microservices, which is why I think service mesh does make sense. And so maybe service mesh is just the wrong name, but I do think people need these capabilities, because a service mesh with just one proxy, to me, is still a good improvement. Remember what we were doing before? You had to write a big ass config file, copy it to the server, restart the proxy. It's like, what was that? Now, if you just had one gateway, even if it's just Istio with one gateway, now you have an actual API, you have a control plane, you can synchronize in real time the configuration. You don't have to restart the proxy. So to me, you can get a lot of value with just a gateway that's just more intelligent and has better features than what we may have been doing before. So that's the way I would like people to think about these tools and capabilities.
Yeah, I think that's progress. I agree. All right, so on to, I think, a question that was asked in the comments. And again, I've got to frame the question. So, I mean, I remember, like many others probably listening, going through my journey at some point, transitioning to really learning Kubernetes and getting my certifications, the CKA and the CCAD, and preparing for them. And part of my preparation, and I want to thank you for it, is going through Kubernetes the hard way. I went through it several times, and it really helped me understand. I love I think someone has said before how if you really want to understand your layer where you're working really well, is you have to look at the layer below, right? And so, you can install Kubernetes with kubeadmin, kubeadm all you want, but you forego the learning lessons of all the automation that tool does for you. So if you just peel that layer and you do it by hand once or twice, now you understand the components and how they interact and how they're configured and everything you need to do to make it work, the certificates you have to generate and place and configure in order to get a Kubernetes cluster up and running. And in retrospect, that tutorial, what I love about it is it's single objective. It's just one thing you have to do, which is stand up Kubernetes, but it's a journey. And along that journey, you learn so much about Kubernetes. And so the question from our audience is, are we going to see service mesh the hard way? Is there even a corollary? I don't even know that necessarily that recipe applies to everything.
Yeah, I mean, it's sitting in GitHub in a private repo, and I'm debating when to open it because it does take a lot of work. There's lots of moving pieces. So what I have so far is like you start with 2 VMs. So I didn't even start with containers. I start with 2 VMs, and I install things like Styra so I can get identity. And so the identity piece, or maybe it's the Spiffy project. So I get identity. I show you how to like get the machines in part of like this identity chain of, hey, if I run a workload by identifying the binary, it will pull certificates. And then I add Envoy to sit in front of this application to use those certificates to talk between. And then I layer on things like Open Policy Agent to make give you the ability to understand like how to make policies between these two requests. And then I layer on something like observability so you can actually see what's happening in the tracing. But what I realize is that you get into a very tricky spot. And I think one of the questions that I'm seeing in the comments is, where do you put the logic? And I remember I went to Twitter right when I was probably 80% done with that tutorial. And it's like, if you're the binary at the lowest part of the stack, how do you know that Envoy is in front of you? How do you know you can trust that anything that reaches you, you should respond to? And it's actually hard because what if there's a misconfiguration? What if someone forgets to deploy the sidecar? Or they deploy the sidecar with the wrong rules? Here you are blindly responding to anything.
Right.
That's dangerous. So there's got to be this handoff between the sidecar and what you give me. And so then it's like, do you go with trust but verify? So even though Envoy is doing the termination of MTLS, maybe it's even extracting the Spiffy ID, calling Open Policy Agent and saying, this looks good to me. I don't know that. Right? So then do I get the Spiffy ID in a header and do this again? Right? Do I call Open Policy Agent myself and say, hold on, let me make sure before I give out this bank account info to the caller that I'm really talking to the right person? So maybe I got to verify the JOT token again. I got to get the Spiffy ID and call Open Policy Agent again. And then I will make the request. So do we duplicate this effort if you really want to be sure? And I think that's an unresolved thing. Some people just say, yeah, you just got to know that the sidecar is there. And if it's not, well, yeah, you'll be on the news tonight. So I think that part I need to find a good answer for, but maybe one day I'll polish it up and then release it. But I do think it will be helpful because I learned a whole lot about each layer of that process and what they do independently, how tightly coupled they are, and then how you should be thinking about it. But that there's some unresolved issues. And then maybe at that point, I'll ship it.
Okay. All right. So perhaps last topic, we'll see, that I want to bring up is a little bit about my journey. I actually took quite a while before from Kubernetes before I really started looking closely at Istio. And again, given my developer background, I remember back in the day doing Java and when Aspect J came out, I remember a friend of mine, Glenn Vanderberg, was doing a talk at a conference about Aspect J. That was a long time ago. The same pattern sort of emerged. And so I went through this exercise, and I'm going to show you this image that I just found on the net. I just Googled, Aspect J or AOP, and I came up with, here it is. This is some random diagram that came up, and it really struck me. And the reason it struck me is because that aspect, that little green box on the left, it says it's even labeled proxy, right? It looks like Envoy in front of a service, in front of an object or a method that you want to protect. And suddenly I realized, wow, I've seen this before, that maybe at a different scale. So let me see if I can paint this image for our audience. Imagine an application, a monolith, running everything in a single process, and you've got these methods that you want to protect or instrument through aspects. And then imagine breaking up that monolith into multiple services that now create, and I love this term, it creates a natural join point at the entrance to every service Here's another image. It's a very, very simple image that shows the process of weaving cross-cutting concerns in aspect J with your code to create a binary that has both mixed together. And we'll come back to that later. And the similarities were uncanny. I mean, I could think about the things on the right being custom resources that you apply to a Kubernetes cluster. And then Istio goes ahead and programs your Envoy. And that's the picture there at the bottom. So I had this epiphany, and the thing I want our audience to maybe take away from this is this idea that maybe this is the new AOP. And I didn't actually come up with it. The first thing you realize when you realize something on the net is that somebody's thought of it before you did. But there are certain advantages to this model. And I think you've already mentioned it. The fact that, for example, with AOP, you have to redeploy a new jar file to change some of those cross-cutting concerns. Whereas here, everything happens at runtime. So imagine you want to modify your authorization policy. You just apply it. You don't have to redeploy anything in this service mesh world. And that's like really, really powerful stuff. And so I want your take on it. I sense that you already figured this out long ago as well.
Well, I mean, honestly, the reason why I like Go, the programming language, is because I think, and look, nothing's wrong with all this OO stuff and aspect oriented and all these fancy things. There's data and there's logic. That's it. All this other stuff is implementation. I know people want to make it all this ceremony. Data is going to come in. You have a state machine that has to manipulate this stuff. Gates will open, gates will close. Things have to happen. That's it. And what we're trying to do when we write code is get as close to that as possible. And I think the platforms that allow you to do that well, things feel like they just make sense. Here's the data model. I have an HTTP request. It has headers and it has a body. I need to operate on that. I don't want to turn that into some class method based class.
Right.
Like, what are you doing?
Keep it simple, right?
It's simple. That's the data thing that's coming in. So when I look at Envoy config and service mesh, I get to operate on those primitives, right? If you're making this request with these headers, you can do these things. Okay, great. Let's move to the next stage. Now I have to process this logic. Who am I processing it for? Give me the identity. I don't know about the interceptor base class user object. Stop it.
Stop it. Yeah.
What identity string am I dealing with? Can I do this? Yes or no? Great. Now I got to take this body and turn it into something that maps to my actual database, right? So now I got to take this class, these properties, and turn them into something that's going to get inserted into the database. Stop. We're doing too much. This is why I think things like gRPC are taking off. Protocol buffers. I have these 5 fields. This is what you want to do. You want to delete the user with this attributes. Great. Give me that. Then I get the request. I get the attributes. I make a decision. I put in the database and return. Stop it. That's it. That's all you probably need. And so I think the industry has been trying all of these designs to make it easier for humans to operate on the data. That's it. That's what programming is, right? Data and algorithms. So the more abstractions we keep putting on top, and sometimes it does make things a little easier. I've seen some benefits of like, especially when you're doing UI, you got to have like a responsive system. You want to have an event come from a drop down. Look, some of that stuff makes sense. These are nice abstractions. But when you go to the implementation, you typically want to just operate on simple data structure with simple programming constructs. This is how we keep things clean. And so, yes, this is why I do think it's important to figure out, yes, maybe we keep things that belong in a service mesh out of our code base so that we can do exactly what I'm talking about. Keep that simple. And then the complexity, let's put it where it belongs so we can focus on the simplicity on the inside.
Well, Kelsey, I want to say thank you so much for sharing your thoughts. It's really eye-opening. And to our audience, you've wasted another perfectly good hour listening to us talk away and philosophizing on service mesh. I hope you've enjoyed this conversation. Kelsey, is there anything else you want to impart to our audience before we sort of close this episode?
Yeah, I think one thing we've been talking about all day is focus on those fundamentals. It's really good to understand the value of MTLS. It's really good to understand the value of observability, because if you understand the problem, the solutions, then I think all of this starts to really make sense. And now you won't be chasing fashion or fads. you'll actually be doing the right engineering thing, bringing in tools to solve the problem that you have because you understand that problem and you also understand what happens if you don't solve that problem.
Super. Well, Kelsey, thank you again for your time. Everyone, I hope you've enjoyed the episode. I'm going to wrap it up with just a few lingering matters. We'll say goodbye to Kelsey, and I'll just close it up in just a couple of minutes on my own. Bye. So for our audience, just real quick, I wanted to cover, the typical tail matter for our episode. I put together here a few links from some past recordings with Kelsey Hightower in different contexts, some of the conversations that I mentioned in this episode. Wanted to mention that Tetrate had a busy June with a variety of events, from our Istio workshop to our WebAssembly extensions workshop, which took place. We'll probably have another roster of those get published on our events page for July. So stay tuned for that. And upcoming episodes, I've got a lot of balls in the air. Nothing's confirmed yet. I'm hoping next week to see if I could get Josh Long to come and join us, but that's not confirmed yet. We'll see how that works out. We've had a proposal on our Slack channel from someone named Maciej about doing some kind of learning Istio from the inside, which is really tantalizing. So I'm going to see if I can figure out how to sort of present that, maybe bring one of our engineers to present it. And then we'll be doing another Tetrate profile in July with one of our customer success engineers, Li Huang. So I'll stay tuned for that as well. Another reminder, this Certified Istio Administrator by Tetrate is something you might want to consider, especially if you've already gone through your Kubernetes certifications, something you might want to look at, and we'll be happy to give you a 30% off coupon if you're interested. And to do that, simply join the conversation on our Tetrate community Slack organization. And the invite URL is there at the very bottom. And so that brings us to the conclusion of our episode. Thank you for your time, and thank you for sticking with us, and we'll see you next week. Bye.